Hey everyone, your board exams are right around the corner, aren't they? So let's do a super fast 5-minute crash course on one of the most important chapters, the human eye and the colorful world. We're going to hit all the key points you absolutely need to nail this.
I mean, really think about that for a second. How does that tiny little lens in your eye manage to see everything from the screen you're looking at right now all the way out to the distant stars? It's kind of mind-blowing, isn't it? This question is the very heart of the chapter, so let's dive in and figure it out.
Okay, here's our game plan. First, we'll look at the eye itself, your own personal high-tech camera. Then, we'll get into common vision problems and, more importantly, how to fix them. After that, we'll check out the magic of light and prisms, finally understand why the sky is blue, and wrap it all up with the top exam takeaways. Let's go.
All right, first up, your eye's amazing camera. Let's really get into how vision actually works. Seriously, just think of your eye as this incredibly advanced camera. We're about to check out all its most important parts.
So, light goes on this little journey just to let you see. First, it hits the cornea, and that's where most of the bending or refraction happens. Then, the iris controls the size of the pupil, deciding how much light gets in, kind of like the aperture on a camera. Next, the lens does the fine-tuning, getting the focus just right, and it projects an image onto the retina, which is like the screen at the back of your eye. Now here's a fun fact. The image that forms there is actually real and upside down. Your brain does all the hard work of flipping it the right way up. Okay, this term is a big one for your exam, so listen up. Power of accommodation. What is it? Well, it's basically your eye's built-in super fast autofocus. These tiny things called ciliary muscles change the shape of your lens, which adjust the focal length. This lets you clearly see things that are close up and things that are far away. Definitely know this definition.
And speaking of things you need to remember for the exam, this number, 25 centimeters. That's the near point for a normal eye. It's the closest you can hold something and see it clearly without any strain. You will see this value in exam questions for sure. And the far point, well, for a normal eye, it's infinity.
So what happens when that amazing little camera isn't working quite perfectly? Well, that brings us to our next section, common vision problems, and how we use the principles of optics to fix them.
Okay. This table right here, this is your absolute best friend for revising vision defects. Let's break it down real quick. First, myopia, also known as near-sightedness. Distant objects are blurry. Why? Because the image forms in front of the retina. The fix is a concave lens. Then you have hypermetropia, or far-sightedness. Now, nearby objects are blurry because the image forms behind the retina. And the fix for that? A convex lens. Seriously, memorize this table. There's one more defect you should know, presbyopia. You can think of this as the age-related one. As people get older, the eye lens loses its flexibility, and that power of accommodation we just talked about, it gets weaker. That's why you often see older people needing bifocal lenses. You know, the ones that have a concave part for distance and a convex part for reading up close?
All right, we've talked a lot about the eye. Now let's shift gears and talk about the light itself. This is where things get really colorful. What actually happens when you shine a beam of white light through a glass prism?
The magic word here is dispersion, and it's based on a really cool fact. White light isn't just white. It's actually a combination of all the colors of the rainbow, all mixed together. A prism is just the perfect tool to split them all back up so we can see them.
So here's how it works. White light goes into the prism. As it enters the glass, it slows down and bends. But here's the trick. Each color inside that white light bends by a slightly different amount. So when the light comes out the other side, all those colors have separated and boom, you get that beautiful spectrum of 7 colors.
And how do we remember the order of colors? The classic mnemonic, of course, VIBGYOR. That's violet, indigo, blue, green, yellow, orange, and red. Now here's the part you have to remember for the exam. Red light bends the least and violet light bends the most. That is a super common question. Awesome! Now let's use what we've learned to answer some of those classic why questions that always seem to pop up on the exam. You know exactly the ones I'm talking about. Here's a big one. You look up at the night sky, and you've definitely noticed it. Some lights flicker and twinkle, while others are just a steady glow. Why is that? What's the deal with stars and planets? It all comes down to distance and our wobbly atmosphere. Stars are so incredibly far away that they're basically just a single point of light from our perspective. As that tiny beam of light travels through the shifting, unstable layers of our atmosphere, it gets bent back and forth, and to our eyes it looks like it's twinkling. Planets, on the other hand, are much closer, so they aren't a single point, they're more like a small disk of light. All the different points of light from the planet average each other out, canceling the twinkling effect and giving us that steady shine.
And now for the biggest why question of them all. Why is the sky blue? The answer is one single word: scattering. The tiny molecules and particles in our atmosphere are just the right size to scatter short-wavelength light, like blue light, all over the place. Think of the atmosphere as a giant disco ball for blue light. The longer wavelengths, like red, they mostly just pass straight through. So when you look up, you're seeing all that scattered blue light coming into your eyes from every direction. This is also why danger signals are red, by the way. Red light cuts through fog and smoke best because it scatters the least. All right, we are in the home stretch. Let's do a final rapid-fire round to make sure these key definitions are locked in your brain for the exam. This is your last-minute checklist.
First up, accommodation. What is it? The eye's ability to adjust its focal length. Simple as that. It's the autofocus.
Next, myopia, also known as near-sightedness. Key points: you can't see distant objects. The image forms in front of the retina. The fix, a concave lens. Got it?
Then we have hypermetropia, or far-sightedness. Remember, it's the opposite. You can't see near objects, the image forms behind the retina, and we fix it with a convex lens. Dispersion. Just remember the prism. It's the splitting of white light into its 7 component colors, vibrobia. And finally, scattering. That's the reason our sky is blue. It's just tiny particles in the air deflecting light, especially those blue wavelengths.
And there you have it, the whole chapter in just a few minutes. From the lens in your own eye to the color of the sky, it's all governed by these amazing principles of light. So here's a final thought. What are you going to see differently in the world around you now? Go crush that exam. You've got this.